So welcome to Sprouts of Science YouTube channel. Myself Sai Kumar Ramawat. So I hope you know that in last class we have cleared about organic chemistry part 1, right? In that class we have discussed about the introduction of organic chemistry. Also we discussed about some scientists who contributed and who synthesized some organic compounds and made the theory which was proposed by the scientist Berzelius called vital force theory gets wrong, right? So when I am discussing about some scientists, I have used a scientist name called Friedrich Uhl. So Friedrich Uhl synthesized an organic compound called urea. When I wrote the equation about urea, I wrote like this, right? You can see that NH4 CNO on heating and rearrangement gives to H2N C double bond O and H2, right? So here you can see this is called as ammonium cyanate. Ammonium cyanate. While this is called as urea, it is an organic compound, well, it is an inorganic compound. You can see here the formula of the ammonium cyanate, that is NH4CNO, while the formula of the organic compound is H2N C double bond O and H2. I said in last class we have here two nitrogens, here we have single nitrogen, but that was wrong. I not noticed this nitrogen. You have two nitrogens here, you also have two nitrogens here, you have four hydrogens here, you also have four hydrogens here. You can have one oxygen here, one oxygen here. If you see the molecular weight, you can get 60 molecular weight here, and you also get 60 molecular weight here. There is no need to balance the equation. So the change was occurred, that is just rearrangement of the elements. Just rearrangement of the elements occur. That's it. So don't get confused. In last class I have said something to balance here. So there is no need of balancing. And I also explained that in last class. So the carbon can singly form nearly 1 crore of compounds, while other elements can form only 60,000 of compounds. What's the reason? If we talk the reason, there are majorly four reasons. What are the four reasons that we discussed one by one, right? So the first reason was the tetravalency. So what is my tetravalency means? You know that when I said you example about propane under hydrocarbon, I said that carbon forms four covalent bonds. Four covalent bonds. So that formation of four covalent bonds is nothing but called tetravalency. What is that we discussed now? So the first reason is called tetravalent. For that, tetravalent. Okay, what is by tetravalence means? The tetravalence means tendency to form four covalent bonds to attain octet configuration. This is nothing but called tetravalent. Here tetravalent is nothing but tendency to form four covalent bonds. Kitna covalent bonds? Four covalent bonds to attain octet configuration. In your 10th class, I think you may are familiar with what is in the octet configuration. Octet configuration is nothing but, so in this nature or in this atmosphere, so all the elements are trying to get their octet configuration. All the compounds and all the molecules try to get octet configuration. The octet configuration is nothing but, if you see here, if you have the atom like this, if you think the atom, this is the atom, and around the atom, so this is the atom. In atom you can find the neutrons, protons and electrons. So these neutrons and protons both combined form the nucleon. What I am saying, you can find electron, proton and neutron. This proton and neutron combined form nucleon. When electrons will be around, means electrons will be what we call, they will revolve around these nucleon, right? So you have proton and neutron on the center of the atom, that is called nucleon, and around the nucleon in a fixed orbit you can find the electrons revolution. I hope you understood. So these are called orbits. So on the outermost shell, means outermost orbit, if you have 8 electrons, that configuration is called octet configuration. Those elements having outermost as 8 valency, which means 8 electrons, they are very stable in the nature, and that is called octet configuration. You know that inert gases, which is called helium, krypton, xenon, neon, radon, these are some elements. These are called inert gases. They has 8 electrons at their outer configuration, right? So remember this point, octet configuration. So what happens, let me see here. How they will attain the octet configuration? You can see here. You know carbon. What is the atomic number of carbon? The atomic number of the carbon is a 6. You all knew that. I'm writing carbon is there 6. You know electronic configuration. Writing of electronic configuration. If you know the atomic number, you can simply write the electronic configuration. 1s, 2s, 2p, like you want to fill the electrons. You see here we have 1s, 2s, and 2p. So maximum electron that can accommodate within the s orbital is 2 electrons. Maximum electron that can accommodate in the p orbital, that is 6 electrons. In case of the d orbital, 10 electrons. In case of f orbital, 14 electrons, right? You see here in carbon you have 6 electrons, 6 protons, 6 electrons, 6 protons, and 6 neutrons. 6 neutrons. You see here how many electrons are there? 6 electrons are there. I'm talking about atom, right? So you can keep 2 electrons here. You can keep 2 electrons here. How many electrons are completed? 4 electrons are completed. And you can keep here 2, right? So why we wrote only 2 here? You can write 6 means the maximum electron that can accommodate within the s orbital, that is the 2 electrons only. I hope you understood. So this is the configuration of the carbon. If you write in the presentation like this, you have 2 electrons. P orbitals are majorly 3. They are the px, py, and pz. How many electrons are there? 2 electrons, 1 and 2. You have 1 empty orbital, 2 half-filled orbitals. And I can write this me like this also. You think like, okay. You have, this is called, let you think, this is a nucleon. What is this? This is a nucleon. And electron, around the nucleon you can find the orbitals. Like this you have orbital. Okay. In orbital you can find the electrons. So if you see here, leave this 1s orbital. I am talking about only 2s orbital and 2p orbital. Let's see here, you are talking only about 2s orbital and 2p orbital. Where do you think this is a 2s orbital? This is a 2p orbital. This is a 2s orbital. This is a 2p orbital. You can see here in 2s orbital how many electrons we have? 2 electrons we have. Let you think it is 1 electron and it is 1 electron. You have 2 electrons, right? So in 2p orbital how many electrons are there? Again 2 electrons are there. So they think here 1 electron is there, here 1 electron is there. This is nothing but electron. This is the electron. This is the electron and this is the electron, right? This is about ground state configuration. What state configuration? This is ground state configuration, right? This is a ground state configuration, means there is no any excitation. Now what I am done means, so I am taking the carbon element. Let you think not only carbon element, you may take any wood. So you just want to take that the compound which is made up of carbon. You may take diamond, you may take graphite, you may take pencil. All these have the what? Carbon. Now what I am doing means I am supplying some energy. What I am doing? I am supplying some energy in the form of heat. Did you think that? In the form of heat, I am supplying some energy to this atom. Did you think it is a carbon atom? I am supplying some energy. So when I am supplying some energy, what happens means this carbon will be, so this atom will be absorbs the energy. What happens? These carbon atom will absorb this energy. When carbon atom will be absorbed that energy, ultimately that energy was absorbed by the lower orbital element. You see here 2s is a lower orbital element, right? So here these element will be absorb the energy. What happens? These element will be absorb the energy. When these element will absorb the energy, electron. When these electron will be absorb the energy, automatically it will be jumps to 2p orbital. What happens? These electron will be jump to 2p orbital. So resultant is same thing. Your nucleon like this, the orbital. Okay. Now what happened? Where 2s orbital has how many electrons? Initially 2 electrons. But when I supplied some energy in the form of heat, what happened? The 2 electrons, then one of the electron get excited and jumped into 2p orbital. So how many was remained? Only one element. Only one electron is present in the 2s orbital. Now in 2p orbital, how many electrons will be present? 3 electrons are present. Why? Because when electron present in 2s orbital was jumped in the 2p orbital due to excitation. Due to excitation, you want to remember. This is the excited state. This is the excited state. Now I am doing carbon. So now you can have that the atomic number is carbon 6. Now I am writing excited state configuration. We have 1s2, 2s, 2s, 2 R1. You have 2s1 only. And 2p3. Why? Because one electron from 2s orbital was jumped into 2p orbital. You have 2s1 and 2p3. Now like this 1, 1. This is the configuration. Now these 4 unpaired electrons will be participate in the bond formation. You can have these 4 unpaired electrons participate in bond formation. Now what I am doing, let me consider one compound made up of carbon. You think methane. I am taking what the example methane. You know the formula of methane. The formula of methane is a CH4. The formula of methane is a CH4. Now you can see I am writing here methane. So here we know that carbon has how many valency? 4 has a valence. Means it has 4 outermost electrons. Like this, one electron is there, here one electron is there, here one electron. It is 4 electrons are present like this. Now in CH4, how many hydrogens are there? 4 hydrogens are there. Let you think here. You have one hydrogen here. You have one hydrogen here. You have one hydrogen here, and you have one hydrogen here. Right? You know that. In each hydrogen, how many electrons are there? Only one electron. Why? Because hydrogen atomic number is 1. You have 1s1 only configuration. How many electrons are there? Only one electron is there. So here one electron is there. Here one electron is there. Here one electron is there, and here one electron is there. Right? Now see this. Now see here. So the one electron of the hydrogen and one electron of the carbon, they will form the bond. They will form the bond here. And they also form the bond. Here also the bond formation will take place. Here also. How many bonds are formed like this? Hydrogen, hydrogen, hydrogen and hydrogen. So CH4 was formed. Here one electron is there, here one electron, 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 here one electron. You see here, how many electrons are there here? 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons, which means octet configuration was attained. Octet configuration was attained. And how many bonds were formed? 4 covalent bonds. 1, 2, 3, 4. 4 covalent bonds. That is mean the tetravalent. You see here, tetravalent definition is tendency to form 4 covalent bonds to attain configuration. Attain octet configuration. Here 4 covalent bonds were formed, and they also attain the octet configuration. Have you understood? This is about the tetravalent. Tetravalent. Due to formation of tetravalent, due to formation of 4 covalent bonds, the carbon compounds will attain the octet configuration, which is very stable in the nature. Which is very stable in the nature. Hence, carbon can form many compounds, massive amount of the compounds, huge amount of the compounds. So you can write all these points. All these points are very important regarding the organic chemistry. Okay, prepare a well and what we call well suitable notes for your understanding. Okay. Now, come to second. This is the first reason. Let me talk second reason. The second reason is so where carbon form the 4 covalent bonds, these 4 covalent bonds will be towards side at the center and form a shape. That shape is called tetrahedral shape. So this tetrahedral shape is very stable in the nature. Very stable in the nature. So you can see the second is the tetrahedral shape. So due to tetrahedral shape, so these covalent bond which is formed by the carbon element, so covalent compound which is formed by carbon element, which is very stable in the nature. How means you can see here, I have carbon, right? Like this I have carbon. So we are talking about methane only, okay? Methane only. Or you can take methane or any compound else. Any compound means here carbon form any bonds? 4 covalent bonds. Here one covalent bond is situated. See here. Here one covalent bond like this. One covalent bond like this. And one more covalent bond like this. And one more like this. Like that. So here you can find like this. This is somewhat solid in nature. So this bond is somewhat solid in nature when I draw on the board. Or anybody will represent the tetrahedral shape. If you want to draw one of the bond very solid and one of the bond very light. So what is the reason for drawing this very solid and very light means? Here this bond is away from the observer. Away from the observer. Away from the observer. If you see here, I have let you think these 4 markers as the 4 covalent bonds. Here, how they are means they are situated like this. Here, you see properly, one bond is like this, and one bond will be remain on upper side, and one bond will be like on this downside, and one more bond will be situated on this back side. One bond is situated on this back side, and this bond which is situated on the back side, that is this one. That is this one, which we cannot able to observe properly, which is away from the observer. Let us think the observer was on this side, so the bond was situated on this side, which is away from the observer. If you observe from this side, automatically this bond will be become away from the observer. You have understood? So actually these bonds are geometrical in nature, which means 3D in geometry. So if you see one side, you can appear only one side. You mostly see only 1D geometry or 2D geometry. You are unable to see 3D geometry. This is why we have represent like this. So this is the away from the observer. A solid line which represent that this is nearer to the observer. This is nearer to the observer. I have understand what are the these light bond represents and this strong bond represents. If you see here, the angle is about 109 degrees 28 minutes. The angle is very important. What is the angle between two bonds in a carbon element or in a carbon compound? That is 109 degrees 28 minutes. So when they talk about the shape tetrahedral, what is the shape of the what is the angle of the tetrahedral shape? They will ask. The angle is 109 degrees 28 minutes. Very important. This is the angle. This is the angle. This is about tetrahedral shape. Very stable shape in the nature. Very stable shape on the nature. So this is one bond. This is one bond. And how many bonds are there? 4 bonds. These 4 bonds are towards a tetrahedron. Towards a tetrahedron. This is called as tetrahedron. Tetrahedron. So 4 covalent bonds. 4 covalent bonds. Covalent bonds situated are faced towards tetrahedron. Remember, this is the second reason. Now we talk about the third reason. So the third reason is formation of the multiple bonds. What is that? Formation of the multiple bonds. What are the multiple bonds? Let me discuss. If you see the carbon can form many multiple bonds. The third reason is multiple bonds. Formation of multiple bonds. So you can see here how means a carbon can form a single bond with another carbon, right? A carbon can form double bond with another carbon, right? A carbon can form triple bond with another carbon like this. And a carbon can form triple bond with the nitrogen like this. A carbon can form double bond with the oxygen like this. You see here, a carbon can form double bond with the oxygen like this. So you can see here a carbon can form single bond with a carbon can form other carbon double bond, a carbon can form triple bond, a carbon can form the triple bond with the nitrogen, carbon can form double bond with the oxygen. Like this, the carbon singly can form many bonds, which is multiple bonds. Due to formation of the multiple bonds, carbon can form many compounds. These are the third reason. This is the third reason. I hope you understood. This is called nitrile. This is called carbonate. This is called alkyne. This is called alkene. If you want to remember, this is called alkane. This is called alkene. This is called alkene. This is called alkyne. This is called carbonyl. Yes, carbonyl. And this is called amine. Amine, or you may write nitrile also. Nitrile. I hope you understood. These are the multiple bonds formed by the carbon. You just remember all these names also. Now, come to the fourth reason, and very important reason that makes that the carbon to form such a huge amount of the compounds. It's very important, right? The fourth reason is the catenation capacity. The fourth reason is the catenation capacity, right? Catenation capacity. What is my catenation capacity? Catenation capacity is nothing but tendency to form. So it is nothing but linking property. So the carbon elements can link to each other to form long chain of compounds. What means long chain of compounds and ring of the compounds. So catenation capacity refers to property of forming long chain of property of linking. Right here, property of linking result to formation of long chain of compounds and ring elements. This is called catenation capacity. I hope you understood my writing. Why? Because I'm going to become future doctor. I will write like this only. Just understand. While I'm pronouncing, I think you may understand. Okay? Catenation capacity refers to property of linking result to formation of long chain of compounds. Property of linking. So linkage property is nothing but linkage property. If I see here, so here carbon is there. Let us think here one carbon is there. Sorry. You have carbon like this. This carbon can form like these bonds. This is called linking property. One carbon get linked with another carbon. Another carbon get linked with another carbon. Like this, by linking, what happened? Long chain formed. What happened? Long chain was formed. So again, you like this carbon is there. Then carbon was linked with another carbon. Carbon here we carbon. Here again carbon. Here another carbon. Like this. This is also linking property. You can see if I draw the NEET structure. 1, 2, 3, 4. Let me think one more. 1, 2, 3, 4, 5, 6. Right? 6 are there? Yes. 6 carbon, which means like this it was represented. Yes. 1 carbon, 2 carbon, 3, 4, 5 and 6. Yes, 6 means how many carbons are there? 6 carbons. In IUPAC, 6 refer to hex. What means? It has 6 carbon, that means hex. And there is between one carbon and another carbon, how many bonds are there? Single bond is there. If there is a single bond existed between two successive carbon, that is called as ane, which means alkane bonds. So we have hex, which means 6 carbons, and it's one type of alkane. Hence we can write ane as a suffix. It is called hexane. You see here, when I'm talking 1, 2, 3, 4, 5, 6. 6 carbons are there. 6 carbon means hex. And how many bonds are there? Only single bond was existed between the carbons. Means ane. What is the difference between these and these? The difference is it is a cyclic one. Well, this is the not cyclic one. This is called aliphatic carbon chain. Well, this is called aromatic carbon chain. Then I can write here cyclohexane. It is just hexane. The difference between. This is called catenation capacity. Catenation is something a property of linking that result to what happens? Formation of long chain of compounds and ring of elements. And some more points also raised regarding the catenation capacity. The first point is nothing but definition. It's a definition, and you also just write these examples. They will give you clear what you call when you open the notes. When you see this diagram, you can understand the concept. No need to wonder to read all these stupid things. Okay. Now come to second point regarding this. So the second point is actually this catenation capacity depends upon the bond dissociation energy. So the second point is catenation capacity. I am writing the CC. Remember, CC is nothing but catenation capacity. CC depends upon bond dissociation energy. Bond dissociation energy. This is nothing but DDE. That's called bond dissociation energy. So catenation capacity depends upon bond dissociation energy. What is meant by bond dissociation energy? Bond dissociation energy is nothing but if you have carbon and the carbon form bond with another carbon. So this is called a bond between two carbons, right? Here one carbon is there, here one carbon is there, and between these two carbon one bond is formed. So I wanted to break this bond. I want to break this bond between these two carbons. What I must want to do? I want to supply some energy. When I apply some energy to this bond, what happens? This bond get broken. So what happened here? Carbon is come, and here for this carbon one electron will become. Here one electron will become. Why? Because A bond is made up of two electrons, and these carbon contribute one electron, these carbon contribute one electron. Here they will share equal amount of electron, and this is called now radical, this is called now radical. Okay, we can discuss in hydrocarbons, not hydrocarbons, we discuss in GOC, right? So here I applied some energy, I supplied some energy. When I supply some energy, this bond get breaked, and what amount of energy is required to break this bond, and that amount of energy is called as bond dissociation energy. Bond dissociation energy, which means here catenation capacity directly depends upon bond dissociation energy. Very important point here. So based on this relationship only we can discuss now. So catenation capacity depends upon bond dissociation energy. How the relationship? So directly proportional relationship. What is that? Directly. If I increase bond dissociation energy, automatically catenation capacity also increases. Catenation capacity also increases. Now, here the bond dissociation energy of the carbon is the, so third point is bond BDE. I am writing BD is nothing but bond dissociation energy. The bond dissociation energy of carbon is 335 kilojoules. Approximately how much? 335 kilojoules. So it is the most, so in total periodic table, so the carbon is the only element that has what we call highest bond dissociation energy. Highest bond dissociation energy in the periodic table, that is only the carbon, absolutely 335 kilojoules. Due to having such a massive amount of bond dissociation energy, automatically has high amount of the catenation capacity. Why? Because we also knew the relationship, that is the catenation capacity was directly proportional to bond dissociation energy. Higher the bond dissociation energy, higher the catenation capacity. Remember this one. So we have highest bond dissociation energy, automatically carbon also has highest catenation capacity. Due to having the highest catenation capacity, it can form long chain of compounds and the what do you call that, rings of the elements. Rings of the element. These are the major four reasons for the carbon to form such a huge amount of the compounds. The first reason is called tetravalent. The second reason is the tetrahedral shape, and the third reason is formation of multiple bonds, and the fourth reason is the catenation capacity and bond dissociation energy. Okay. So in next class we can discuss about how to represent an organic compound and how to find the hybridization regarding the organic compound. Hybridization is very important, and what is the formula that we can use to find the hybridization. So in every year of the NEET exam there is a question regarding hybridization. So how we can find, I will give you how to find. We have a trick sum, we have some formulas, we want to applicable that. We can discuss about steric number, and we also discuss, if there is a time, how to find number of hybrid orbitals and how to find number of pure orbitals. What is my hybrid orbital, what is my pure orbital, everything we can discuss, right? So these are about today's class, and this today's class we have discussed what regarding the major reasons that was contributed the carbon element to form such a huge number of the compounds. So write the notes very well, prepare at the same day what I explained you. Okay, maintain the good notes. Having the good notes only makes you the well person and a good person regarding the exam. Okay, don't get stressed, everything will be going a final way. Okay, thank you, and keep watching this video. Subscribe the video, share the video to some more people and some more students for their bright life. Thank you.